So the first part of this tutorial used GeoGebra to study the properties of the derivative and to understand the motivation and where the derivative comes from. So now that we have that knowledge, we're going to go further in the tutorial, and we're going to use GeoGebra to create a derivative guessing game. So I've got us in the algebra and geometry view, and so we're going to go to the input bar and we're going to type in a function f of x equals 1/2 x squared plus 1. So that'll create a parabola for us, and we will right click on the function and go to object properties, and we'll click off show label. We'll change the color to blue, and then we'll go to the style tab and we'll change the line thickness to 5. Okay, and so then what we want to do is we want to create a point on the parabola. So click create point and then click on the parabola, and that'll create point A on our parabola. So just make sure that, move A around, make sure that it's actually tied to the parabola, and it is. So then what we want to do is we want to create the tangent line to point A, and our function f. So go to tangent and click on the function, click on point A, and that will create the tangent line. So then we want to go ahead and modify the object properties of the tangent line. So we'll also click off the show label. We'll change the color, we'll make it red, and we'll also change the line thickness to 5. Okay, so we can see what the value of the derivative is at that point. Let's go ahead and create the slope triangle of the line, and that will create the number m, which will give us the value of the slope of our tangent line to our function. And we can see as we move point A around, we can see how the tangent line, or the derivative to the point, changes. And we can actually see the value of the derivative at the point through the parameter m. So now what we want to do is we want to create another point. So we want to do this from the input bar. We'll call that point B. So B is going to equal x sub A, and what that will do is give us the x coordinate of point A, and for the y coordinate we want to use the slope of the tangent line. Hit enter, and that creates point B, and then we want to connect point A and point B with a line segment. So go ahead and right click on the line segment, the object properties. So again, we'll take off the show label and we'll make the line a little bit thicker. We'll go to 3, and for the line style, let's make it a dash line. And what that will do, now as we move point A around, we can actually see our point B will trace out the derivative function. Okay, and so to actually see that trace, we can right click on point B, object properties, and click on show trace. And now as we move point A around, it will actually trace out the derivative function for our function f of x, which in this case is a parabola. So as we showed in the first part of this tutorial, the derivative of a parabola is a line, and we can see that that is indeed the case here. So what is the derivative of our function f of x equals 1/2 x squared plus 1? Well, we can see from the trace that it's a line. It goes through x equals 0, so the y-intercept is 0. And if we actually turn on the grid, move point A around, get our trace again, what we can see is that when we go over change x by 1, that y changes by 1, so our slope in this case is 1. So what we have here is the function y equals x for the derivative function of our function f of x equals 1/2 x squared plus 1. So what we actually want to do in this case, though, is we want to create a derivative guessing game. And so to do that, we want to take advantage of Geogebra's symbolic processing capabilities to calculate the derivative for us. And so in order to do that, let's go ahead and go to the input help, and we'll look at all commands, and we'll look for the command derivative. And there it is. So let's click on derivative. And so we can put in the derivative of a function, and it'll actually give us the derivative. So let's call the derivative dd. Let's say that equals the derivative of our function f of x. And what that will do is it will actually plot the derivative, and you can see from the left corner of your screen, it'll also tell you what the derivative is. So in this case, the derivative of our function 1/2 x squared plus 1 is equal to x. And then we can see x plotted in the graphics window. So let's go ahead and modify our derivative. And so let's take off show label. And for the color here, let's go ahead and change the color of the derivative. So in this case, let's make it green. And we'll go ahead and increase the line thickness to 5. Okay, and there's our derivative. So now, when we move around point A with our trace on, you can see that we'll trace right over the derivative that we calculated with Geogebra. Okay. So now we'll take advantage of a feature in Geogebra called dynamic text, and we'll go ahead and click on text, and then we will type in the derivative is, and then we'll have a colon, a space, and then we'll go over to objects, and we'll click on objects, and we'll find our derivative dd. And so you notice when we put in dd up here, it puts in the object, but in the actual preview for the text that will actually show up, it replaces what the value of dd is. So in this case, it tells us what the derivative is. So the derivative is x. Okay, and then so we want to modify this text with object properties. Go to text, let's change it from small to medium, and we'll make it bold. Okay, and so now because we want a derivative guessing game, we don't always want to show the derivative. So now we'll use another feature called the checkbox. So go and click on checkbox, click above the derivative, and then in the caption we'll say show derivative, and then we will link that checkbox to our derivative function, and we will also link it to our text. So what this will do is when our show derivative checkbox is checked, it will show the derivative function plotted in our geometry window, and it will show our text box that tells us what the derivative is. Okay, and we want to move that around, and we can see that our checkbox is given the value C, and when it's checked, it's true, and when it's unchecked, we can see that C goes false. And when it goes false, we can see that both our plot of our derivative function, dd, and our text that tells us what the derivative is, both go away. So now if we check it, we can see what the derivative is. If we don't check it, we don't have the derivative. Okay? So then, what we also want to be able to do is we want to be able to control whether we have a trace of our derivative or don't have a trace. So let's create another checkbox. Check somewhere over to the right of our graphics view, and we'll type in show trace. Okay, but this one we won't link to anything. Let's make sure things are lined up properly. And that looks good. Okay, so in order to control the trace, we want to go ahead and just search our input command help commands, and we can see here that there's a Geogebra input command called set trace. Okay, and so if I say set trace, I say the object, and then I say whether it's true, which means I'll set the trace on for that object, or if it's false, it means I'll set the trace off for that object. Okay, and then so there's another command, Geogebra command. So if we go and search for if, we can see that Geogebra has an if command, and so I can say if and then use brackets. I set a condition. If that condition is true, then what follows after the comma will be done, and then if I put another comma, if it's not true, then I'll do that what's in the else block there. Okay, so I want to use these in the script portion of my set trace. So I'll go to Object Properties, go to Scripting, and you can see that this, whenever my checkbox is updated, then it will execute these commands in the Scripting tab. Okay, so I want to use the if command. So I want to say if my checkbox, which has the name D, so if D is true, meaning that it's checked, then I want to use the set trace function for object B, and I want to set that true, which means I'll turn on the trace. And then if D is not set to true, which means it's unchecked, then I want to set the trace for B to be false. Okay, and then I also want to use another if, and I want to say if D is equal to false, meaning if it's unchecked, then I would want to use another function called zoom in, and I want to zoom into the magnification level of 1, but effectively what this is going to do for me is it's going to remove the trace. So whenever I uncheck my show trace box, I want the trace that I had to go away. Okay, and then so go ahead and hit OK. And now when show trace is checked, then it will actually trace out the derivative function when I move my point A around. If I uncheck point A, then it will turn off the show trace, and it will actually make my trace disappear. So I can start off without showing the trace at all and without showing the derivative, and I can see if I can guess the derivative of my function with no trace. So then if I want to get the next level of information, then I'll click show trace on, and that will actually turn the trace on, and then I can make a guess for my derivative function. If I think my derivative function is y equals x, then I can click show derivative to actually show the derivative and see if I am correct or not. So I've got most of the makings for a derivative guessing game. So the last step, what I would like to do is I want the ability to actually change my function. So go up into input box. So I want to create an input box somewhere above show derivative, and I want my caption to be function, and then for linked object I want to link that to my function f of x. Okay, and so what that will do is it will have an input box which will allow me to change my function. So before I change my function, I want to go to Object Properties, and I want to go to scripting. So first of all, so whenever I change my function, what I want to do is I want to take off the checkboxes for show derivative and show trace. So to do that, I want to use the Geogebra command set value. Okay, so what set value does is it'll set the value of my checkbox. In this case, I'll use C. I'll set C to false, and that will uncheck my show derivative checkbox if it's checked, and then I want to set value for my checkbox D also to false, so that'll take off the trace. And just to make sure everything is set properly, I want to set trace for B, which would be my point B, to false, just to make sure that it's not going to trace out any new values there. And then I also want to do my zoom in level to 1 to clear out any existing trace that exists. Okay, so go ahead and enter those commands, and every time I change my function now, so on update of my function f of x, it will do all these things. It will uncheck my checkboxes if they're checked. It will set the trace for point B to false in case that's set to true, and then it'll set my zoom in value to 1, which effectively in our case will just remove any existing traces. Okay, so let's go ahead and play around a little bit with our function as it exists now, 1/2 x squared plus 1. Go ahead and let's turn on the trace, and let's move our point A around, so that'll trace out our derivative function, y equals x. Okay, and then let's go ahead and click show derivative, and that'll show the derivative for us. So in this case, my derivative function is not where I want it to be, so let's move it back here. And if you want, you can fix all of these values. So if you click on fix object, then these things will not move around, and will stay in the proper relation to each other. So make sure all of the boxes are fixed, and then if we change the zoom level, then we won't change the location of the derivative checkbox like we had just seen happen to us there. Okay, so now we have everything clicked, so let's go into our input box and let's change our function. So we want to have a different function now that we're going to try to guess the derivative of. So what we'll do is we'll type in sine of x, and now we can see that our trace disappears, and then our checkboxes now go to unchecked, and our derivative function goes away. So now we can try to guess what the derivative of the sine function is. So let's go down to point A with no trace on, and let's go ahead and move point A and see if we can guess the functional form of our derivative. So we can see our tangent line, we can see how it changes, and then we can see the value of that slope of that tangent line reflected in our value b. So it looks like our value b is also tracing out some kind of a sine wave, and the amplitude looks like the amplitude of that is comparable to the amplitude of our sine wave, but they're definitely not in phase, right? So they're peaking at different positions. So to get a little bit more information, let's go ahead and click on show trace, and now we'll go ahead and trace out the derivative of our sine function. So now we can see pretty clearly that at x equals 0, our derivative function has the value of 1. The amplitude is the same as the sine wave. And so it looks like to me that the derivative of our sine of x is the cosine function. Okay, so that's my guess. So let's go ahead and check the guess with show derivative, and that'll plot out the cosine function, and you can see that it tells us that the derivative is cosine of x, and it indeed is, our trace overlaps the cosine function. So that's pretty nice. It looks like things are working as we expect. Let's turn off our input help, and let's also go ahead now, since we can see a lot of our information in the algebra view, and to make our game complete, now let's turn off the algebra view. Let's go ahead and put on our axes. Okay, let's move our graphics window a little bit now. Move that back where it's supposed to be. Okay, so now we can no longer see any information about the derivative from the algebra window. So let's go ahead and type in a different function. We'll type in the function f of x equals e to the x, or the exponential function. Okay, so now let's go ahead and move around the point A, and you can see right away that the point A and B correspond with each other, right? So that's a pretty easy derivative function to guess. So it looks like the derivative for the exponential function is just the exponential function, right? So we can click on Show Trace, and you can see that the exponential function is going to trace out exactly over itself. And then we can click Show Derivative, and it'll plot the derivative. So the derivative of the exponential function e to the x is e to the x, and we can see that they all trace out, trace right over one another. So to make that a little bit clearer, if we want, we can change our function to e to the x plus 1. We can offset our exponential function by 1, and so now we can separate the point A and the point B. So in this case, we can see that the plus 1 is a constant and just offsets our exponential function, but the derivative of that constant is 0, so we'll still get the exponential function as our derivative, but we can see it a little bit more clearly now. So let's go ahead and turn on our trace. And we can see that we trace out the exponential function. And so when we type in Show Derivative, it'll plot out our derivative, which overlaps our trace, and we can see that the derivative is indeed e to the x. So this is kind of a fun little game that gives you an opportunity to play around with different functions, try to guess their derivatives, and turn on or off the trace dynamically with checkboxes, and show the derivative that actually will link dynamically to text, which will link to what the derivative of our actually given function is in this case, and play around. And so, try this out. Learned a lot of new features about GeoGebra and how it can link dynamically to allow us to study the properties of functions, and in this case specifically the derivative function. So that ends this tutorial on using GeoGebra to study the properties of derivative, and we'll see you again next time.